All right, welcome back for day 3 of Advent of Code. I started the recording a little late today, so the problem is already open, and we'll click right into it. First off, a quick shout out to Arc, the browser I'm using, which makes it super easy to build some custom CSS rules so that I can display this on the side of my monitor instead of having it all run off the screen, because you can see how big it's supposed to be if we scroll all the way to the left. Okay, so some elf has an important job of loading all the rucksacks, which are like backpacks or something like that, with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, so a few items now need to be rearranged. Each sack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per sack. The elves have made a list of all the items currently in each sack, which is the puzzle input, and our job is to find the errors. Every item type is identified by a single lowercase or uppercase letter, so A to Z for lowercase and uppercase. And the list of items for each sack is given as characters all in a single line. A given sack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. Interesting. Okay. For example, suppose you have the following list of contents from 6 rucksacks. So each line is 1, and we split right at H, so it's first half, second half. And we're looking for, it looks like, which item is shared between them. There's a priority, so basically an index number for A to Z lowercase and then A to Z uppercase. The sum of each item is what we care about. Find the item type that appears in both compartments of each rucksack. Okay, so we have to split this in half. For each half, we have to identify the letter that is the same between them. Each of those letters is assigned a number. So for each line, we find each of those letters and then we sum the results. So quite similar to what we've been doing for the past couple days, actually. So again, our setup is I have 2 bins. They bring in the library function for anybody who hasn't seen the other days. We've got a main function for each of these binaries. The part1 imports the process part1 function. We read the input to a string and then we process it. And in our library, we have a test. So we drop the test input here in a string. And then we have 2 tests. One is part1 works, and one is part2 works. That uses process part1 and process part2 respectively. So the sum for these numbers for part1 is 157. So we'll save that. I'll start running the tests, which will immediately fail. So I'm thinking that we don't even have to start off with an iterator. We can take the slice, we can get the length of the string slice, and then provide 2 views. So we do 0 dot dot, whatever the halfway point is, and halfway point dot dot, whatever the length of it is. And then we have first half, second half as 2 string slices. And then we can iterate over the first and do dot includes on the second. That could go into a filter or a filter map, probably, which will return each of the letters. And then we also need something that holds the score for those letters. So I'm thinking we can just create a vec of A to Z. I don't remember if there's a conversion between ASCII characters or not for those scores. So maybe I start there. I keep wanting to type concat, but is it append? What is going to get me a second iterator here? I am kind of blanking on it, so I'm going to go look at the docs. So standard iterator in the Rust docs, which is docs.rust-lang.org. I'm going to open the sidebar, which is going to give us a bunch of methods. Now that I think about it, do I even need to do that? Because if I do a dot dot capital Z, what does that give us? Let's do into iter dot collect, and we'll collect this into a vec of cars for now. And then I'm going to debug letter scores, which is empty. Okay, what did I do wrong? Oh, you know what I probably did? That's probably an invalid range. Yeah, okay, so here we've got A through Z, and it does need to be dot dot equals. I think realistically, I just don't know my ASCII ordering correctly. Yeah, so the problem is that if I do A to Z, we get from A to Z, but the next one would be curly brace. So if I do this, I think this will work. Yeah, so we get these curly braces on the end, for example, but the capital letters come before that. So we do have to do both A to Z and A to Z. Is chain what I was thinking of? Let's go look at chain. Chain here. Takes two iterators and creates a new iterator over both in sequence. Yes. And that's how you find these things. You just Google some stuff, you check your information, and then chain a dot dot equals z. I think we need to do into iter, but I guess it's possible that we don't. Yeah, okay, so range implements wow, I am doing so good with the words right now. So there's standard iter chain, and if we look at range, we don't want BTree map range. We want standard ops range. Range has chain implemented on it because the implementation for chain takes anything that can be turned into an iterator and then does it for us. So that's what's happening there. So chain isn't actually implemented on range, if I'm reading this correctly. Chain here, if we scroll up and I don't miss the impl for whatever is here. Why did I get the exact size? Okay, impl iterator for range. Okay, great. It's iterator for range, which implements chain, and chain as a function takes anything that can be turned into an iterator, and ranges can be turned into an iterator. So you can call the function into iter, which is what we were doing before on range, which is why chain works here. Okay, I'm stumbling over myself today, but it's okay. Hopefully you got some value out of learning how to look things up when your brain hits the brakes. Okay, but all that to say that we have the letter scores here now, so I should be able to do, let's do like capital F and debug that out. So this takes a closure and we do C equals F because we're iterating over characters, or did I mess that up? Oh, right, because I enumerated. So letter scores is now an iterator for A to Z and capital A to Z in sequence. If we do iterator.enumerate, that gives us the index and the thing that we were looking for. So this will be like the index and this will be the character as a tuple. And then that'll probably be a reference. So I'll just, I think it's a reference to the tuple. Yeah, okay. It's a reference to the tuple. We destructure the reference off the tuple. Actually, I should show you how I knew that. So we can't compare a reference to a car with a car. That's how I know that we're comparing a reference to a car in C with a car F that I wrote here. And yada yada, it's like partially car, whatever, isn't implemented for reference to car. And if we scroll up, the other error that I saw earlier, we had a can't compare reference to tuple with car. So I know that C in this case, which is the whole argument, is a reference to that tuple, which is how I knew to put that there. But also, if we look at the type signature for find, it actually does tell us that too. So this is going to be a little awkward because I have it so zoomed in. Let me find that again. There we go. Let me find. So find takes the generic argument P, mutable reference to self. So we call this on an iterator. Self is an iterator in this case. And then the argument that we pass to it is the predicate, which is the closure. The closure uses the fn mute trait, which is, there's a handful of function traits. There's fn once, fn mute, and stuff like that. And what this means is basically there's a closure here that takes a reference to the items in the iterator, so self item, and returns a Boolean. So if you really needed to go and figure out what this was for some reason and you couldn't figure it out by trial and error or guessing or reading the error messages, you can always go read the function signature in the docs. That's how we know this is a reference to a tuple. And we aren't using index, so I'm going to do underscore IDX so that Rust doesn't keep warning us that we haven't used a thing that I'm not intending to use at all anyway. And we see 31F. So all that to say, I think we have to add 1 to the index. A through Z have priorities 1 through 26. So if we do lowercase a, we're going to get 0 here, I think. Yeah, so we get 0 here. So maybe we find map, and find map returns an option, I believe, from the fn mute, and also takes ownership of it. So we could do like if C equals A, IDX plus 1, else none. And you'll see I've gotten really used to Rust Analyzer just reformatting my code for me like that. And we need to wrap this in sum. So that gives us our number. So A is 1. You can see that I'm using debug here. So dbg, the macro, will print out this entire expression for me, as well as the value of that expression. So here on source lib.rs line 3, we have letter scores enumerate, find map, if c equals whatever. And then we have this little equal sign at the end that says the value is sum1, which is really cool. So we have a way to find the scores. It's a little awkward, but we have a way to find the scores. We could also collect this, but I'm going to leave it as an iterator for now anyway. So capital A will have 27, and then that should make Z 52. So we're good. We have all of our letters and the scores associated with them. So I'm just going to leave this code here and comment it out because we'll need that to find the scores later. And then we'll take the input like we talked about earlier and get the length, probably divide it by 2. We'll do sac length equals that. We'll grab a slice. So from the input, we want 0 dot dot sac length and let, I guess these aren't sacs, right? These are like compartment A and compartment B. And we'll take a slice from the input again and we'll do, I think we'll start at sac length. We'll do sac length times 2. I'm assuming that everything that we get here is even. I don't know that for sure. So then what we need to do is take compartment A, iterate over it. Iter will give us references, so we're not allocating anything there. And we want to find the character. I always forget if it includes or contains. I think it's contains. Contains C. Oh, you know what I didn't do? We need to do this in a loop, actually. That was silly. So input.lines.map line. This will be our function body. I'll wrap this whole thing in the closure. And in here, we don't want this to be input. We want this to be line. Compartment A.iter looks like it's complaining. Oh yeah, we don't want iter, we want cars. So cars will give us an iterator over a string slice, giving us each car. And I believe that we need to do as stir here. But I didn't check the error message. So because this is an educational exercise, let's do, what's the error? The error says expected an FN car closure found car. Okay, I think that's from no, it's not from before. So the other error is saying contains needs to have a pattern. That seems like the real error. So let's just dereference the C that we get from cars, which is a reference if we look at the types. So I brought the type inlays up. This C is a reference to a character, and we need to dot contains an actual character. So I save that, and we get yellow lines because we're not using those values anywhere, and Rust wants us to know that. Be like, hey, you're not using this code, not using the value. I highly suggest setting up type inlays if you haven't set that up yet. It's so useful. I don't have them on all the time. I find them distracting to have on all the time. So I have them bound to a key binding, which you can also do. Okay, so compartment A, find whatever. This is the common car, and this is when we need our score. And it's not if C equals car, it's common car, which Rust is also warning us about. Expected car found enum option. This always needs to succeed, otherwise we've done something wrong. So I'm gonna unwrap it. And then we're doing a use after move here because the line here is a FN mute, which captures the result or captures the variable. So we have options. In this case, what I'm going to do to solve that is we have letter scores up here, and I'm just going to clone it every time instead of recreating it every time. We could have also moved letter scores into the inside of this closure here. I chose not to, clearly. There's also a number of other ways we could have set up letter scores. We could have set it up as a hash map with cars as the keys and values as the right-hand side. Actually, that's probably significantly more efficient. So we need to do an into iter, and then we can map. Well, we're going to enumerate, and then we'll map, and this will give us the index and the character, and we will return the character and then the index plus 1. We have to import hash map from standard collections hash map. So now we have a hash map that is letter scores. And now we don't have to enumerate over it or find map. And instead of doing the clone that we were doing before, we've now moved letter scores. We've chained our two ranges together. We've gone into iter because it doesn't have iter. It only has into iter. We enumerated over that to get our indexes. We mapped over that and translated this into a tuple. So we've got the character in the first slot and the index in the second. If you collect a tuple, you can collect a tuple into a hash map where the key is on the left and the value is on the right, which is super useful because now we don't have to do some like weird iterate over and insert into a hash map a bunch of times kind of thing. And now we don't have to clone letter scores. We can just reference it because all we're doing is reading that value out. So we map over all of that. This is going to be let result equals this thing. Result is now going to be used down here, which is great. This is still an iterator because we're not closing it. So let me do, what do we need? .sum on this value? I think we need .sum. And because we need a type, we'll do U32. And then everything complains because I forgot that this is an option. Yes, I forgot that this is an option. So it can't infer the sum type. We gave it no way to do that. Sum does take a generic argument when it's called. So we want to do sum of U32. Oh, right. You know what I didn't do correctly? Get is an option, but this should always succeed. Okay, so the problem here is that because we used indexes to define the scores, the indexes are defined as usize because indexes in Rust are usize. So we collected into a usize, and I was trying to use a U32 as the result. But when we letter scores.get, we get a usize out of that, and we can't sum a usize into a U32 because a U32 is smaller. If you're unfamiliar with usize, it's basically the platform unsigned integer size. So it could be like 64 bits, or it could be, I think it could be like 128 or something like that if you wanted it to be. But basically it's platform dependent. So it could be bigger than a U32. And anytime you have to go from bigger to smaller, Rust is going to be like, hey, you know, you might have an issue here. So you either have to use as to do that or some other operation so that you are encoding that you're truncating it potentially. In our case, I don't think it gets that big. Usizes are pretty big, but we'll just stick with usize instead of converting. So all in all, I believe our test is now passing. Yes, our test is now passing. So the test we set up ages ago is now working. So 157. So let's, before we celebrate, run this and make sure that I get my puzzle input and don't use yesterday's puzzle input. That would be good. So this is why I do panics here. Because if the input is malformatted, it's an issue with something I did, not with, oh, I don't want to copy that. Why did I copy that? Let's copy the input. Let's drop this in here, all the bags. So yeah, if this program panics because all of this input is really well formatted, it's a me problem. It's an I didn't use the right input or something like that kind of problem. So that's why I leave those as panics instead of getting out like the wrong answer, because the wrong answer in adventive code is really rough to deal with. Did I really just copy a single 7? I'm chugging today. Okay, so that was the right answer. So 7967 for me. We got a gold star, and we can continue to part 2. So as you finish identifying, okay, let's cover part 1 first. Recap, we need to score each of the letters. This input is a list that looks like this right here. This list is split in half on each line. So the left-hand side is one bag and the right-hand side is one bag or one compartment or one container. I forget what they called it. So we get the input, but the first thing we do is set up the scores. So we iterate in a range, or rather we set up a range from A to Z lowercase, and then we chain that with a range from A to Z uppercase, and we iterate over that. So chain is taking one iterator and basically dropping in the second iterator right on the back of the first iterator. And then we call into iterator. We enumerate over that to get the index of each of these items. So A will be 0, lowercase a, and capital Z will be 51 or something like that. We map over this because what we really want is a hash map. So we create a tuple where the first character, or the character is in the first slot of the tuple, and the index +1 is in the second slot, because we don't need a 0 to 51 count. We need a 1 to 52 count, because in the problem it's 1 indexed, and in indexes it's 0 indexed. So we collect that into a hash map because collect can do that for us. It can take a bunch of tuples and throw all the keys in the right spot and all the values in the right spot. Then we take the input and we go, each of the lines gives us a single bag. The length of the bag cut in half is the length of a container. So this is misnamed as a variable. Because the bags are all strings, we can just reference a slice of that string. So we go from 0 to sack length, which is non-inclusive. So we go from 0 to up to and not including the sack length. And then we do the same slice for the second bag, but we go from the sack length up to the sack length times 2, because that will give us the last index. And these are both going to be string slices. So we get a string slice as the line. Well, let's put it this way. Our input comes in as a string slice. We iterate over it. We map, which comes in as a string slice for each line. Each compartment is also a string slice. So we've done no allocation to get this information so far, aside from creating the scores. So we need to find the common character between these two strings. So we do compartment A.characters.find compartment B.contains this character. If it does contain, this is going to return true, which will give us some value. So find can fail, right? If we give it a number as a string or something like that, or a number as a character, or like a dash or a curly brace or something, this find would fail. So that's why it returns an option type. We unwrap that option because this is always going to succeed for us because there's always going to be an item in both. So we get that common character and we go to our hash map and we say, get this by reference. And that grabs us the value for this key, which can also fail. You can imagine if we passed in a dash here, that would not be able to find a value. So we unwrap that option, we return that from the map, and then we sum it all up into usize, and that goes into result, and we return the result. So part 2 then, as you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Each elf carries a badge that identifies the group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their sack. And at most, 2 of the elves will be carrying any other item type. So I think what it's saying is that one of the elves is carrying nothing but B. That can't be right though, because the input has 3 bags. This is one of my issues with Advent of Code every year. They kind of make you do a word problem, and sometimes the wording is incredibly ambiguous. If a group's badge is item type B, then all 3 elves will have item B somewhere in their sack, and at most 2 of the elves will be carrying any other item type. That to me says the 3rd elf can only be carrying item B, right? But that can't be true because each of these bags is many items. So I don't know what they're trying to say there. So the only way to tell which item type is the right one is finding the one item type that is common between all 3 elves in each group. Okay, so we need to take groups of 3 bags now. We still need to find the priorities, so that priority hash map is still going to be useful. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. So that's the halfway point, right? So there's no r in the second half of this, so we're not doing that half and half algorithm anymore. Okay, so we need to start getting 3 of these and then doing what we just did, but do it for 3 of them. That shouldn't be too hard to write. So let's start with grabbing this. Well, no, actually, let's start with the sum of these items is 70. Let's start with enabling our test. So this will be 70, and I will unignore that test, which should now fail. 1 passed, 1 failed. And then process part 2 will start off with the setting up the letter scores in the same way we just did. And then we need to do something like input.lines.chunks. Can I do chunks? Array chunks? Is array chunks going to work? I feel like that doesn't work there. Array chunks is a nightly only experimental API. Returns an iterator over n elements of the iterator at a time. This is what we want. Iter array chunks. Maybe we'll enable nightly. I like nightly. So what we need to do if we're going to do this is grab this and drop it in. I'm going to drop it in up here right at the top of the file. I think that we are going to lose Rust Analyzer here. Cargo plus nightly watch hex test. Okay, it looks like we're good, but Rust Analyzer is still going to not like us. It does look like the size of the chunks comes in as a type argument here. So here's what I'm doing here. There is a tracking issue for iterator array chunks. Array chunks is a nightly only API. Rust comes in a number of different flavors, including stable and nightly. Nightly is built every day and shipped every night, whereas stable is what you're familiar with. It's Rust 1.65 or something like that. I'm assuming because this issue is open in August 12th that it doesn't matter really what version I have because I update all the time. But to enable nightly features, you do need to do hash bang feature and then the name of the feature, which in this case is iter array chunks. It does look like we have a constant usize as a type argument to array chunks that we do need to specify. Is there an example usage somewhere? Maybe. So I kind of guessed based on what I was reading from the tracking issue. The tracking issue says it takes a const argument. So this const is everywhere, but on the array chunks function, there's a type argument here, a generic, that is n. So I just slapped that in right there. And let's hope that that works. Chunks is an API that exists in third-party crates like iter tools. So it's cool to see it in the standard library as well. I think also chunks is on slices. So if we were going to get a slice of the input, we could have collected lines and then ran chunks on it. But array chunks is an API on iterators. So because I've never used this API before, I believe we'll be able to map over this. Let's set up our result here equals this. And let's set up that. And let's do all of this. And let's just do like result 0 or something. And because this collect is going to be finicky and something that I just randomly did, let's do vec of strings or string slices. So I've chosen to go with a vec of string slices because I know that there will be somebody in the comments saying, I would love to see you do this more incrementally. The way I would have done it personally is just ignored the fact that there was an error here and kept writing. But here's what it looks like if you do need the confidence of having seen it debug out. So you can see that we do get A, B, C, which are each of the bags, A, B, C, each of the bags. And it's not overlapping, so there's only 6 of them, which is wonderful. It's exactly what we need. Now, this second half of part 1 is exactly what we need. So let's grab this and get rid of that. And this won't be a collect. This will be a sum of usize again. Result 0 will not be a reality anymore. I'm going to name this variable a car, even though I should probably name the other one bag. We're going to do contains a car. So we're looking for the common car here. Same thing that we were doing before. Bag A, bag B, and bag C. A.cars will give us an iterator over all of the items in bag A. Then we will try to find that character in bags B and bag C. And we try to find that, which should always exist because this is how the problem was set up. And then we get that common car from the bag or from the hash map, and then we sum it. So I haven't scrolled down to see if this has worked yet. I just saved it. So if we scroll all the way down, let's find out if this worked. 2 passed. Okay, so that works. That's exactly what we needed to do. So we'll do cargo plus nightly bin part 2. Oh, cargo plus nightly run bin part 2. Oh, I left the debug in there, didn't I? Darn it. Let's get rid of the debug. Let's just run it. 2716, and let's hope that that's the answer, because that would be great. Hey, right answer. That was a gold star. Go us. Let's return to our advent calendar. We start getting a little bit of an ASCII art image. So the more questions we do, the more we get better. The more we get better. The more we get correct. The more ASCII art will unveil. And at the end, we get a nice picture. So we have that to look forward to. So let me click back in here again quickly. Okay, so we've got our letter scores. Again, 2 ranges changed together, thrown into an iterator. I think we need this into iter. I had it before we had chain. We don't need the into iter because range.chain range apparently gives us an iterator. So let's get rid of that in part 1 as well. You do have to call into iter on a range, but if I do .chain on the range, then I guess we get an iterator. And we can check that by doing the type inlays, which does show impl iterator item equals car for the return type of chain. So we chain these 2 ranges together, we enumerate over them, we set up our tuples, the key is the character, the value is the index plus 1. We get that into a hash map using collect because collect is amazing. And this syntax that I'm using here is called turbofish. It is : open angle bracket, the type that you're collecting into, close angle bracket, function call. And what we need to do here is we need to get the first 3 and the second 3 and figure out what character is common between each of the groups of 3. So we do lines to separate this into each of the lines for each of the bags. We do array chunks, which is a nightly API, and we pass in a generic const number of 3. We enabled this API using the feature config flag, whatever you want to call this, with the iter array chunks feature name. And when we run, we use plus nightly when we do cargo. So cargo plus nightly run to opt into the nightly toolchain. If you don't have nightly, you will need to do something like rust up. I forget what you have to type. It's rust up install nightly or something, rust up add nightly or something like that. But I have so many things installed that it's always just around, and I haven't needed to do that in months. So once we get each of the chunks, so we get an array here of 3 items. So if you're unfamiliar with arrays in Rust are sized. They have a set number of items. If you are coming from JavaScript or another language and you have an idea of what an array is from that language, that concept of an array in JavaScript is a vector in Rust. So for us, when we say this is array chunks, we are saying that we are going to get exactly 3 items in an array from doing this, which means we can destructure it with values A, B, and C. I probably should have called these bag A, bag B, and bag C. I didn't. So we map over the chunks, we destructure this array, we get each of the bags, we use the first bag as like the source bag. We could also do something where we like looked for the smallest bag to do the least number of lookups, or we could like have like uniqued these into a set and then tried to do it that way. That's too much complication for us for now. We don't need to do that. So we just take the first bag we're given, we do a cars on it, which gives us an iterator over each of the characters, each of the code points, actually, technically speaking. Then we do a find. We take the character that we're iterating over. We check to see if it exists in B. We check to see if it exists in C. If it exists in both, then we return it and we unwrap that value. Then we get common car. This is the common car to all the bags. We get that from the hash map, which will always exist because of the way the problem is set up. So we unwrap it, and then we sum that, each of the values for each of the groups of bags, into a usize, and we return that result. So this was a fun one today. Hopefully you learned a little bit. I tried to chop it up a little bit more than I probably otherwise would have, partially because I'm a little tired right now and I want to go to bed. And my brain wasn't quite working. So I had to look some stuff up in the docs. And also partially because some people asked me to go into it a little deeper in the last video. So I'm trying to go into it a little deeper, trying to show you where I find things in the docs when I can't remember them and stuff like that. So as always, questions in the comments in the comments, give me a thumbs up or whatever if you liked it. And I will see you tomorrow for day 4. Have a great rest of your day.